Welcome to this very first lecture of the Wisest King Academy. Today, we are going to work in a topic under financial math, and the topic is sequences and series. And precisely, we are going to look at a subtopic under sequences and series called arithmetic progression. Now, the question we should be asking is, what is a sequence and what is a series? A sequence is a group of terms in a well-defined order. Group of terms, group of terms in a well-defined order. That's a sequence. For example, we have 1, or let's say 2, 4, 6, 8. We have 3, 9, 27, 81. We have 100, 96, 92, 88. We have 10,000, 5,000, 2,500, 1,250, and so on and so forth. Now, when we talk about the sequence, there is that tendency of you knowing how it evolves. For example, when we look at the first example here, we notice that the next term is obtained by adding 2 to the previous term. 2 plus 2, 4. 4 plus 4, 6. 6 plus 2, 8. 4 plus 2, 6. 6 plus 2, 8. Now, for the second, the next term is obtained by multiplying the previous term by 3. We have 3. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. Likewise, for the third, the next term is obtained by subtracting 4 from the previous term. 100 minus 4, 96. 96 minus 4, 92. 92 minus 4, 88. The last one, the next one is obtained by multiplying the previous by 0.5 or by dividing the previous by 2. We have 10,000 divided by 2, 5,000 divided by 2, 2,500 divided by 2, 1,250. So these are sequences. When you observe, there is that tendency of you knowing which value will come next. Now, a sequence might be in an increasing order or decreasing order. An increasing sequence is a sequence whose first term is the smallest term. For example, the first and the second examples here, they are increasing sequences. Meanwhile, the third and the fourth are decreasing sequences. A decreasing sequence is a sequence whose first term is the highest term. Now, looking at a sequence now, a sequence may also be finite or infinite. A sequence is finite if the last term is known. Let's say this ends at 1,000. Let's say this ends at 40. So you see, example 1 and example 3 are finite sequences. Their last terms are known. Meanwhile, sequences are infinite if their last terms are unknown. For example, example 3, example 2, and example 4, their last terms are unknown. And such sequences always end with 3 dots. So, before solving a question, understand how does the sequence evolve. Okay, remember the topic is sequences and series. After looking at the sequence, the question will ask ourselves, what is a series? A series is actually the sum of the terms in a sequence. Sum. When you bring together and combine all the terms in a sequence, they form a series. So I will say here, sum of the terms in a sequence. Now, if we take for example, we have 2 plus 4 plus 6 plus 8 plus pamper pam pam plus 1000. That's the series of this first sequence. We have 3 plus 9 plus 27 plus 81 plus pam pam pam. That's the sequence, the series of the second sequence. We have 100 plus 96 plus 92 plus 88 plus pam 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 plus 40. Likewise, 10,000 plus 5,000 plus 25,000 plus 2,500, sorry, plus 1,250 plus. So these are the series of the sequences of. Now, to ease our understanding, sequences and series do not only hold for quantitative elements, for numbers. Yes, there are some qualitative elements that actually follow a sequence. Let me go progressively. If you look at the grading in school, they are A, B, C, D. They follow a sequence. If you look at the days in a week, they follow a sequence. Monday, Tuesday, Wednesday, Thursday, right up to Sunday. Months in a year, they follow a sequence. Now, when we combine the days in a week, they become a series. That series become a week. When we combine the days, when we add all of them, they become a week. Remember, the series is the sum of the terms in the sequence. When we combine the months that we have, the 12 months, they form a series of what? 1 year. Okay, another example, TV programs like Prison Break, The Good Doctor, El Diablo, La Beauté du Diable, Rosa, Catalina, Terra Nostra. We call those things series. Why do we call them series? It's actually because they are made up of episodes. Now, if, for example, you watch an episode where it ends, where Marima wants to slap Sergio, and it cuts there, the next episode that will come, it will begin where she wants to slap Sergio, and maybe slap Sergio. That's where it continues. So you have that tendency, after watching a previous episode, to like say, this is the way the next episode will look like. The same thing for the sequences here on the board. So when they bring those episodes all together, when they group them, they become what? A series. So it holds also for qualitative variables. But now, why are we looking? Remember, sequences and series is actually an introduction because we are entering the subtopic arithmetic progression. Remember, note, a sequence, whether it be an increasing sequence, a decreasing, finite or infinite, sequences generally evolve in two ways, either arithmetically or geometrically. That is why we have arithmetic progression and geometric progression. Arithmetic progression actually deals with plus and minus. Geometric progression deals with multiplication and division. And that is going to take us into our topic of the day. Now, I'm not going to wipe these examples up because we are going to use them. So, arithmetic progression. Arithmetic progression. Let me abbreviate. We call it AP. Now, a sequence is an arithmetic progression, or an arithmetic sequence is a sequence in which the next term is obtained by adding a constant number to the previous term, which is called a common difference. I repeat, a sequence is an arithmetic progression if the next term is obtained by adding a constant number called the common difference to the previous term. Now, let's consider these terms to be the terms of an AP. T1, T2, T3, T4, right up to Tn. Now, we want to see here how we can calculate the nth term, the fifth term, the sixth term, the nth term. Calculation of the nth term, which is actually Tn. Now, the first thing we are going to do is this. Before we get into the nth term, let's look at what arithmetic progression is all about. We say it's a sequence in which the next term is obtained by adding a constant number to the previous term. So we look at this. If we take that constant number, which is called the common difference, if you get into the sequence, the difference between any two successive terms will give that difference. That's why it's called a common difference, meaning it's the same everywhere. So that common difference, either you take T2 minus T1, either you take T3 minus T2, and so on and so forth. Right up to maybe Tn minus Tn minus 1. Tn minus 1 is the previous term to Tn. Now, let's come now to calculate our nth term. Let's take our first term, T1, to be A. If our first term is A, now, the second term will be, remember, we add the constant number, that's the common difference, to the previous term. The previous term to T2 is T1. To it, we add the constant number. Don't forget that T1 is equal to A, so this will be A plus D. Let's go to T3. T3 is going to be T2 plus D, which is equal to A plus D, which will be A plus 2D. T4, that's going to be T3 plus D, which is A plus 2D plus D, which is equal to A plus 3D. Now, we want to generalize. Look at it. The coefficient attached to T here is less than the base. The coefficient attached to D here, is less than the base attached to T here by 1. For example, when we have 0, 1 here, we have 0t. 0 times t is 0. That's why you're not seeing anything. Now, when we have 2 here, we have 1d. Is d here, but the coefficient attached to it is 1. When we have 3 here, we have 2d's. When we have 4 here, we have 3d's. So, therefore means that the coefficient attached to d is less than the base attached to t here by 1. So, if I have tn, I will first of all put my a plus. Now, what's the previous term to n? Is n minus 1. So this n minus 1 are multiplied by d. This is the way the formula of the nth term is derived. The nth term, the 10th term, the 50th term, the 100th term. So let's use our example. Let's calculate T20. Let's calculate the 20th term of the above progressions. Now, these examples are both. Example 1 is an AP. Example 4 is an AP. Remember, arithmetic progression has to do with plus and minus. The first one, the next term is obtained by adding 2. Here, the next term, example 3. Example 3 is an AP. The next term is obtained by subtracting 4. So for each and every one of these arithmetic sequences, we are going to calculate the 20th term. Now T20, let's take the first one. If we take the first one, the first term A is equals to 2. The common difference, you can calculate it either by taking 4 minus 2, or you can still take 6 minus 4, or you can still take 8 minus 6, which will still give you the same 2. So having that, we can calculate T20 now. T20. First term, that's A, plus n minus 1. 20 minus 1, that's 19t, right? 19t, that's 19 times 2. 19 times 2 is 38. 38 plus 2, that gives 40. So the 20th term of that progression is 40. Let's take example 2. If we take example 2, the first term of example 2 of this is 100. The common difference will be either 96 minus 100 or 92 minus 96 or 88 minus 92, which is equal to minus 4. So our T20 here, we have A plus, our A is 100 plus 19, that's 20 minus 1 times minus 4. So let's calculate. Let me take a calculator. 19 times 4, 76. That's 76. That's negative 76. So 100 minus 76 is going to give 24. So T20 is equals to 24. That's the 20th term. Okay. So that is how we can calculate the end term of an AP. Now, let's look at the sum of the first n terms. This one we call it Sn. The sum of the first n terms of an AP. Now, first 20 terms, first 50 terms, first 100 terms. Now, this will actually be given as follows. Sn equals to T1 plus, T2 plus, T3 plus, T4 plus, pam 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 plus, Tn. Don't forget, please note this. T1 is A, T2 is A plus D, T3 is A plus 2D, T4 is A plus 3D, T5 is A plus 4D, T6 is A plus 5D, T10 A plus 9D, T20 A plus 19D, T50 A plus 49D. So please note, put this in your head. Don't forget this. So if we want to expand this, we are going to have A plus D plus, A plus 2D plus, A plus 3D plus, pam 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 plus, A plus N minus 1D. Now this can be summarized by the following formula. N divided by 2, big bracket open 2a plus bracket open n minus 1 times d. This is the formula to calculate the sum of the first n terms of an AP. It is very easy to master this formula. If you look at a plus n minus 1d, is the formula of the nth term. So you simply add 2a and n divided by 2. It gives you the sum of the first n terms. So what we are going to do, we are going to use these are two previous examples on which we calculated, or with which we calculated the 20th term. We are going to calculate S20. That's the sum of the first 20 terms. Now let's use example number 1. With example number 1, don't forget we know our first term, we know our common difference is still on the board. The first term is 2, and the common difference is 2. So S20 here will be 20 divided by 2, big bracket open 2 times 2, minus plus 19 times 2. 19 times 2, 38. 2 times 2, 4. 4 plus 38, 42. 2 divided by 20 divided by 2, that's 10. 10 times 42, that's going to give us 420. If you can take your calculator and be adding 2 plus, 4 plus, 6 plus, 8 plus, right up to the 20th term is going to give you 420. Now, with the second example, S20 will be equals to 20 divided by 2, big bracket open 2 times 100. Don't forget, our first term is 100. Plus 19 times minus 4. 19 times minus 4. I believe you all get a calculator. If I take 19 times minus 4, it's going to give us minus 76. 2 times 100 is 200. So 200 minus 76. 124. 124 now, 20 divided by 2 is 10. 124 times 10 will give us 1,240. So that is the sum of the first 20 terms for the first example and the second example. So you can observe, you can go through on the board. So we are going to solve some application exercises on arithmetic progression. Now, after we have solved these exercises, you can, in fact, the link of these exercises will be in the comment section, in the description section below. Please download the question, go through the question. I have about 7 questions there. I'm going to solve about 3, 4 of those questions, and you solve the rest. Please, please attempt them. Share those who you know these lectures will be useful to them. Please share. Invite them to subscribe to the channel. Let's help ourselves. Okay, let me get the question. Okay, these are the questions. So I'll solve example 1, question 2, question 3, and maybe question 4. And you solve the rest. You solve question 5, 6, and 7. Okay, let me wipe the board. Okay, question number 1. I read question 1. Jam Company began production in 1999. In the year 2000, it produced 22,000 units. And in the year 2001, it produced 24,000 units. Calculate the production for the year 1999 and the total production by 2005, given that the production followed an AP. Now, this company started production in 99, 2000, 2001, 2002, 2003, 2004, 2005. Now, what does this mean? It means that 1999 is T1, 2000 T2, 2001 T3, T4, T5, T6, and T7. It means the total production by 2005, it means this company must have been producing for 7 years. And don't forget, here we have A, here we have A plus T, A plus 2T, and so on and so forth. Now they have given us the production for the year 2002, the year 2000, it produced 22,000 units. And in the year 2003, it produced 24,000 units. And we have been asked to calculate the production of 99. Production of 1999, which is actually T1, which is actually A. Now, please notice when you're solving a question in arithmetic progression, your calculation should lead you to calculate the first term and the common difference. Because when you know these two, you can perform any calculation. In fact, anything you'll be asked in the question will lead you first of all to calculate these two things. If they are not given, or if one is given, you need to calculate the other to be able to calculate actually what you have been asked. Now, here, to calculate the production of 1999, we first of all need to calculate the common difference. And since they have given us two successive terms, production of 2001, production of 2000, that's T3 minus T2. That's going to give our common difference, which is actually 24,000 minus 22,000, which is actually 2,000 units. So it means every year, the production of jam company increases by 2,000 units. Now with this now, don't forget that T2 is equal to A plus D, meaning A will be equal to T2 minus D, which will be 22,000 minus 2,000. So the production of the year 1999 is actually 20,000 units. Now, they say we should calculate the total production by 2005. What does this mean? Total sum of the first n terms, that's Sn, which in this case is going to be what? S7, because from 1999 to 2005 is actually 7 years. So if we look at this, how do we calculate Sn? Sn is equals to n divided by 2, big bracket open 2a plus a2, n minus 1 d. So our S7 here will be 7 divided by 2, big bracket open. 2 times 20,000 plus 7 minus 1, 6 times 2,000. So if we look at this, will be 3.5 times. 2 times 20,000 is 40,000. 6 times 2,000 is 12,000. 12,000 plus 40,000 is 52,000. So this is 52,000. So the total production by 2005, we are going to take 3.5 times 52,000. That's 182,000 units. 182,000 units. This is the total production by 2005. And that is actually question number 1. So please just observe. Any question, please, you can ask it on the comment section. Don't forget, subscribe to this channel, share the link, share to help other people and equally to help me. Okay, I'm not going to wipe it. I'll use the other section of the board. Example number or question number 2. Mr. John carried out a series of payments in April. The sum of the third, 7, and 12 was 220,000 francs. If the 8th payment was to third, the 12, calculate the first payment and the common difference. Not to the sum of the first 5 payments. Wow, this is a nice question to apply arithmetic progression. Now, Mr. John carried out a series of payments in April. They said the sum of the third, T3, this is question 2, T3 plus T7 plus T12 is equals to 220,000 francs. Let me remain here. Don't forget, T3 is equals to A plus 2D. T7 is A plus 6D. And T12 is A plus 11D. And all of this is equals to 220,000. So if I summarize A plus A, that's going to be 3A plus 2D plus 6D, 8 plus 11, 19. So that's 19D equals to 220,000. This is my question number 1. Remember, anything you're doing leads you to calculate the common difference and the first term. Now let's come to the second relation. We are told that the 8th term is to get the 12th term. T8 is equals to 2 over 3 T12. If we cross multiply, this will imply that 3T8 is equals to 2 T12. Let's expand that. 3 T8 is A plus 7D equals to 2 T12 A plus 11D. So we expand the bracket, we have 3A plus 21D, 2A plus 22D. So we bring the like terms together. We are going to have 3A minus 2A equals to 22D minus 21D. So this minus will give us A, which is equals to this minus will give us D. So it means that A is equals to D. And this is actually our second equation. So we can substitute this in the first equation to have A. So we substitute that. What are we going to have? 3A plus 19A equals to 220,000. 3A plus 19A will give us 22A, which is equal to 220,000. So A will be equal to 220,000 divided by 22. So A is equal to 10,000 francs. Don't forget, A is the same as D, so this is still equal to D. So we know our A, we know our D, and that was the first question. And that we can now calculate the sum of the first 5 payments. That's S5. Don't forget, Sn is equal to n divided by 2, big bracket open, 2a plus into n minus 1d. So our S5 here is not Samsung S5 here, it's S5. Sum of the first 5 payments. So this will be 5 divided by 2, big bracket open, 2 times 10,000 plus 4 times 10,000. How do I get 4? N minus 1. That is 4 minus 1. So we are going to have here 2.5, big bracket open. 2 times 10,000 is 20,000. 4 times 10,000 is 40,000. 40,000 plus 20,000 is 60,000. 60,000. Now, 2 times 60,000 is 120,000. 0.5 times 60,000 is 30,000. 120,000 plus 30,000 will give 150. So our S5 will be 150,000 francs. That is the sum of the first 5 payments. So we are done with that question. You can still observe why I can wipe this first part to solve question 3. I'm also going to type this question on the screen so that when you're looking at the solution, at least you can know what it's all about. But if you're really determined, if you have a printer, you can print this question. It will help you a lot. So that as you're going through the video, you can be seeing actually what we are solving. But if you have 2 devices, you can download the question in one, and while you're watching on the other one, you can see. Okay, we go to question 3. Question number 3. Mark arranges to pay off a debt of 9,600,000 francs in 48 monthly installments, which form an AP. When 40 of these installments were paid, Mark became insolvent, and his creditor finds that 2,400,000 francs still remains unpaid. Find the value of the first 3 installments paid by Mark. Ignore interest component. Okay, now Mark has to pay how much? 9,600,000. In how many installments? 48 installments. So this means that if we sum S48 is equal to 9,600,000. This is nice. So let's look at how do we calculate Sn. Sn is n divided by 2, big bracket open, 2a plus b into n minus 1d. So S48, that which is 9,600,000, is going to be 48 divided by 2, big bracket open 3, and 2a plus 47d. Don't forget, 47d. So we expand again, 9,600,000 equals to, this divided by this is going to give 24. 2a plus 47d. Let's expand the bracket. So 9,600,000. We are going to have 24 times 2 is 48. So 48a plus 24 times 47. Wow. 24 times 47. 1,128. 1,128d. This is our equation 1. Now, with the second, they say after paying 40 installments, 40, the creditor finds out that 2,400,000 was still left. So it actually means that S40 will be equal to 9,600,000 minus 2,400,000, which is actually equal to 7,200,000. So let's use the formula and expatiate. So we are going to have S40, which will be equal to 40 divided by 2 big bracket open, 2A plus 39D. Don't forget. So we have 7,200,000 equals to 20 times 2A plus 39D. So if we expand, 7,200,000 equals to 40A plus, normally it has to give us 80, that's 78, 780D. That's true. 780, but let me confirm. 39 times 2, 780. Okay, this is actually going to form our equation number 2. We have two equations, two unknown. Can we solve? Yes. So let's go. 48A plus 1,128D equals to 9,600,000. 40A plus 780D equals to 7,200,000. So let's take 40 here and let's take 48 here. So we'll do that. 40 times 48. 1,920. 1,920A plus 40 times 1,128. We are going to have 45,120D equals to 40 times 9,600,000. 384 million. So multiply 48 times 40, that's going to give us 1,228 plus 48 times 780. 37,440. 37,440D equals to 48 times 7,200,000. 345,600,000. 345,600,000. So we can now subtract this minus this because 0. Let me just do this one at once since I have it on my calculator. 384 million minus my answer here. I'm going to have 38,400,000. So I now take 45,120 minus 37,440. 7,680. 7,680D. So it therefore implies that D will be equal to 38,400,000 divided by 7,680. So what is that going to give us? 38,400,000 divided by my answer. My D is equals to 5,000 francs. That's the common difference of that progression. Now, let's substitute it in either of the equation. I'll choose equation number 2. So it means I'm going to have 40A plus 780 times D. That's times 5,000. That's going to give me 7,200,000. Right? So 40A will give me 7,200,000 minus. So 5,000 times 780. 3,900,000. 3,900,000. So 40A will be equals to 7,200,000 minus 3,900,000 give me 3,300,000. So it therefore implies that, permit me to write here, A will be 3,300,000 divided by 40, which is equals to, let's go, divided by 40. 82,500. So 82,500 francs. Remember, this is equals to T1. The social calculator, the first 3 payments, right? We have calculated the first. To have the second, T2, we simply take what? A plus D now, which will be 82,500 plus 5,000. which will give us what? 87,500 francs. T3, we simply take T2 plus D, which will be 87,500 plus 5,000. That's going to give us 92,500. The question is solved. So, please observe. Observe. I hope you are enjoying the solution or the solving. Now, I wanted to solve just 3 questions, right? So, let me solve 4 questions on this paper. 4. Please go through. If you have other questions, you can still send them to me, right? Send them to me and I will joyfully solve it. Or joyfully solve the questions. So, let me clean the board. Let me clean the board. Should I start this way? Okay, let me allow the one on the board first. I'll start this way. If the board is not sufficient, if I like, we go to question 4. Question number 4. I read, Solo owes his partner. No, that's number 5. Question 4, sorry. 2 posts are offered to a person. The first carries a starting salary of 100,000 francs per month and an annual increment of 4,000 francs. The second carries a starting salary of 90,000 francs and an annual increment of 5,000 francs. Assuming that he has to work for 25 years, or he has worked for 25 years, which job does he have to select? Now, very, very important. This person works for a year. Now, after a year, he has an increment. So what we are going to do, let's first of all take option 1. Option 1, let's calculate his annual salary. First, annual salary. That's actually our A. So the first option is 100,000. So say times 12. His first annual salary, which will actually be the first term of the progression, will be 1,200,000 francs. Can we see that? Now he has an annual increment. So total annual increase, which is actually the common difference. He will be added, for the first option is to receive 4,000. So 4,000 times 12, which will give 48,000 francs every month. Every year, sorry. That's what will be added to his salary every year. Now that's the first option. Now, they say if he has worked, if he's worked for 25 years, so N is equal to 25. Which option should he choose? So what we are going to do here, we need to calculate S25 in both cases. So we do this. Don't forget, Sn is equal to N divided by 2. Big bracket open 2a plus a2 N minus 1 D. So S25 here will be equal to 25 divided by 2, big bracket open 2 times 1,200,000 plus 24. That's 25 minus 20 minus 1, which is 24, times D, which is 48,000. So S25 in this first option is going to be, remember this is 12.5 times. This times this is 2,400,000. So 2,400,000, 2,400,000 plus 24 times 48,000. 3,552,000. 3,552,000. So we multiply by 12.5 times 12.5. We're going to have 44,400,000 francs here. This is what this person is going to have for the first option. 44 million means over a period of 25 years, the total money that he must have received is 44,400,000 francs. Now let's take option 2. If we take option 2, first annual salary, which is our aim in that case, is going to be 90,000 times 12, right? 90 times 12 is 108. So this will be 1,080,000 francs. This is going to be his first annual salary. The common difference, that's total annual increase. That's the common difference. We are going to have 5,000 times 12, which will obviously actually be 60,000 francs. So we come down, we need to calculate S25 in option 2. So S25 will be 25 divided by 2, big bracket open, 2 times 1,080,000 plus 24 times 60,000. So let's calculate 2 times 1,080,000 plus 24 times 60,000. That will be 3,600,000. So this will be equal to 12.5 times 3,600,000. So S25 here is going to be, we say times 12.5. 45 million. Wow. 45. Whereas here we have just 44,400,000. So you discover that the total accumulated, that's accumulated the aggregate of the salaries for that 25 years. Second option is 45 million. First option is 44,400,000. So the second option is greater by 600,000 francs. So if it were you, which one would you choose? Which one? Well, another person will say that I will choose the option of 100,000 and maybe save the surplus 10,000 in a bank. Well, that is nice. Very nice. But from the look of things, let's assume no interest, nothing, no option for the bank. Which option will you choose? The second option is better because over a period of 25 years, you discover that the man must have earned 45 million compared to the first one, which will be earning an annual salary of 1,200,000. Yet, for 25 years, you will barely earn 44,400,000 francs. So the second option is better. Okay. So you have question 5, question 6, question 7. Please, please, please subscribe to the channel. I hope you find these lectures useful. Our next lecture on financial maths will be on geometric progression. So this will be sequences and series 1, which is arithmetic progression, part 1. Sequences and series part 2 will be geometric progression. We will still have questions like this to solve also. So please subscribe to this channel. Please, students at advanced level. If you are a teacher, you have students at advanced level, please send them to subscribe to the channel. If your students at the university level, please subscribe to the channel, share the link. Thank you very, very much. Thank you. Until then, we'll meet in the next video.